Okay? So log base 3 of x equals -3. So if we loop-de-loo that, what will we write? Whenever we loop-de-loo, what number do we start with? Always. We start with the base. Always start with the base. So 3, right there's the base. Start with that number. So 3 to this power equals that. Well, what does 3 to the -3rd mean? How do we do negative exponents? 1 over. So this is going to be 1 over 3 cubed. And what's 3 cubed? 27. So the answer is 1 over 27. That's the answer to the question. Okay? Now, this one is going to be kind of the same thing, except there's no base. Or is there? Is there a base on ln? Yes, there is. Anybody know what it is? Okay, one day we talked about this. LOG, if you just see LOG, that means the base is 10. If you see ln, that means the base is e. This is log base e. Now you don't have to rewrite it. You can just slip a little e in there if you want to. It's up to you. You need a base though. Because if we're going to loop-de-loo, we got to have a starting number. So our starting number is going to be e. So e to the x equals 1 over e to the 5th. E to the x equals 1 over e to the 5th. Well, what power would give me a 1 over e to the 5th? What would that power have to be? -5. Doesn't it have to be negative because of the 1 over? So our answer is -5. Log base x of 19 equals 1. All right, so if I loop-de-loo this, what number do I start with? X to the 1st equals 19. Well, that's easy. What does that mean? X equals 19. Done. Can you do D on your own? What's X? You're trying to figure out what X is. So loop-de-loo it, starting with what number? 5. So 5 to the 2nd equals X. So what's X? 25, yeah. That's easy. You can do that. Now what's missing on this problem? There's no base. So you got to put one in. Kids, you have to have a base because that's the number you start with when you loop-de-loo. Well, LOG, the understood base is 10. There are 2 times when you won't see a base. One is when you see LOG and you'll put a 10 in, and one is when you see LN and you'll put in an E. Then you can go ahead. So 10 to the x equals 1,000. Anybody know know how many tens it takes to get 1,000? 10 times 10 times 10. How many of those it takes? How many? 3. It takes 3. 10 times 10 is 100. Times another 10 would be 1,000. So x equals 3. I don't want to fill your mind with useless information, but the number of zeros here tells you how many tens there are. So if there's 3 zeros, it means 10 to the third. If there's 4 zeros, it means 10 to the fourth. F. There is no work for F. This is a property. Anybody remember the property? It's automatic. There's no work to do. Don't write anything down but the answer. The answer is 36. The answer is 36. This is the answer. When these two numbers match, when your logarithm is an exponent, when the base of that logarithm matches the base of that exponent, the answer is just that extra number. And last one, G, the last one on this side. All right, what are you going to do? How are you going to start it? You should be writing something on your paper. What are you writing? 4 to the x equals 64. And then you just got to figure out 4 times 4 times 4 times 4 times 4 times however many 4s it takes to get 64. So 4 times 4 is 16. Times another 4 is 64. So how many 4s does it take? 3. So x equals 3. Okay? Now we got some simplified. We already took a quiz over this, but we can't, we need lots of practice, so here we go. Tell me what you're going to do with that. 1 over. So anytime you have a negative, it's going to be 1 over. Okay? Negative exponents mean 1 over. On the front side, we had a 1 over e to the 5th. And you made that e to the negative 5th. Those are the same thing. Negative exponents mean 1 over. All right. What does 16 to the 3/4 mean? What do fractional exponents mean? Radicals. So this means 1 over the 4th root of 16 cubed. Remember, in a fractional exponent, the denominator tells you the root, and the numerator tells you the power. Okay, what's the 4th root of 16? 2. And 2 cubed is 2 times 2 times 2? 8. So the answer is 1 over 8. Don't forget the 1 over. It's 1 over because of the negative. And then we took the 4th root of 16 and cubed it. This one, 1/2 to the negative 3rd. What's the negative going to do? Flip it. So instead of being 1/2, it's going to be 2 over 1, or just 2. Mm-hmm. And then the exponent becomes positive, so the answer to the question is 8. 2 cubed, 8. Pretty easy. What about this one? 64/27 to the 2/3. Well, it looks very scary. But what does the 2/3 mean? What what do I do with an exponent that's a fraction? We'll turn it into a radical. So this is going to be a radical. Under the radical is 64/27. The radical is going to be a cube root squared. Remember, the denominator tells you which root. So here we go. Now we gotta know some stuff. What's a cube root of 64? 4. What's a cube root of 27? 3. Don't forget though, now you have to square it. So what's 4 squared? 16. And 3 squared is 9. And that's the answer to the question. Mrs. Ford, how do I know the cube root of 64 is 4? Well, ideally you'll have that memorized. But if you don't, you have to figure out what number times itself 3 times gives you 64. So you can try 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. There you go, you got it. Five to the negative second times 10. What do you think you should do first? So this is going to be 1 over 5 squared, which is 1 over 25 times 10 over 1. Straight across, remember it's a no calculator, so we multiply straight across, we get 10 over 25, and then we can reduce that. 2/5. Okay, now number 3 and 4 are from a while ago. We haven't reviewed these. So you're going to have to dig back in your memory. It says we got a couple of points. And we're going to write the equation of the exponential function containing those 2 points. Oh, does anybody remember anything about this? What? So what is the form of the equation, Ruby? Do you remember? Y equals?
A times B plus CX.
Perfect. Beautiful. That's your exponential. That's what an exponential looks like. Your job is to figure out A and B. Okay? Now, does anybody remember anything about how we go from here? Jill? We plug in a point, and which point do we start with?
0.
The one that has a 0. So 4 equals A times B to the 0. Pick the point, one of the points will always have a 0. Pick that one first. Now, when I put 4 in for Y, remember these points are X comma Y. So 4 in for Y, 0 in for X. Okay? What's B to the 0th? 1. So doesn't this just say A equals 4? Do you remember that always happening? That always happens? Okay, so Y equals 4B to the X. That's where I'm at right now, because I figured out A was 4. All right, what happens now? Plug in the other point. So now we have 16/9 equals 4 times B to the 2nd. Joshua, you keeping up with this? coat you have on?
Jacket.
Okay. Are you supposed to be wearing that? No? All right. Who knows how to start this? We gotta figure out what B is now. You know how to do this. What do I have to do first? Divide by 4. Now, kids, let's not overcomplicate this. Because this is a fraction, I can go ahead and do divided by 4, but that's gonna be a mess. So it might be easier in this case, instead of dividing by 4, to multiply by 1/4. By this stage of your life, you should know those are the same thing. Dividing by 4 is the same as timesing by 1/4. I don't care which one you do. I think it's easier when fractions are involved to do it this way. So that's going to be 16 over 36. Now what do I do? What? Square root. I gotta get b by itself, so I'm gonna square root. What's the square root of 16? 4. What's the square root of 36? 6. Uh-oh, I think that reduces. 4 over 6 reduces to 2/3. Now that's my b value. So now I can write my answer. Y equals 4 times 2/3 to the x. Remember, y equals a times b to the x, like Ruby said. You already figured out a was 4. You just figured out b was 2/3. So now we can write our equation. Hopefully that's jiggling some memories. Several of those in your notes if you need to go back and review. Okay, number 4. This is an exponential equation. You see y equals a times b to the x in number 4. Is it a growth or a decay model? It's a decay. How do I know it's a decay? Because 0.71, the number with the exponent, is less than 1. If that number, this b number here, this would also be a decay because that is less than 1. What's the percent growth or decay? Now, let's not mess this up. You've already told me it's less than 1, right? How much less than 1 is it? 0.29. How much less than 1 is 0.71? How much less than 1? That's your percentage. Your percentage is not 71. It's 29. It's a 29% decay. Because 0.71 is 29 less than 100. What's the initial value? 62. A is your initial value. So just like in this problem, our initial value was 4. In this one, the initial value is 62. Okay, everybody? So next time I see you, Wednesday, we're going to have a quiz. And the quiz is going to have problems on it exactly like this. Now, I'm not sure, it might be this long, it might be a little bit shorter, but it's going to have these problems on it. Okay? All right. Okay. Now, let's get back to our notes then. And continue on with, what is this, section 3.5? Yeah. So we're on number 4 in our notes, section 3.5, page 29. Wowzy. wowsy, wowsy, wowsy. This looks very scary. Let's see if we can solve this. Now, I want you to think of it in big terms as a regular equation. All right? So if you have something like this, what kind of just sticks out to you as maybe something we should do to get the ball rolling? Subtract the 3. Now be careful, because what that's going to leave you with is negative 2 log base 6 x plus 2 equals 2. Don't lose that negative there. When you subtract the 3 to cancel it off, you're left with negative 2 log. Perfect. What's the next step? Divide by negative 2. You can't have this number out in front, guys. Get rid of it every time. So now we're going to divide by negative 2. When you divide, it doesn't change anything. It just cancels that out. So it's log base 6 x plus 2 equals negative 1. We need to get rid of this logarithm. How do we get rid of a logarithm? Dilute it. That's exactly right. So we start with the base. So 6 to the negative first equals x plus 2. Would you agree? What's 6 to the negative first mean? 1/6. So 1/6 equals x plus 2. And then what? Subtract 2. So 1/6 minus 2 equals x. Would everybody agree with that? Now, I don't care how you figure this out. You can think of it as mixed numbers if you want, or you can get a common denominator. So 1/6 minus 12/6. 2 is 12/6. So 1/6 minus 12/6 would be negative 11/6. If you thought of it as negative 1 5/6, that's perfectly fine too. However you process 1/6 minus 2. Wow, you guys did a great job with that. Good work. All right, how about this one? What do you think? Just think about a regular equation. What would be the first thing you might want to do? Actually, think about it as an equation like this, guys. If you had an equation like this, would the first thing you would do divide? Is that what you do? No, wouldn't you add the 2 over? That's probably the best way to start. It isn't the only way to start, but it's going to mean no fractions. If you divide it first, you'd have fractions. I think it's easier to go ahead and add the 2 to the other side. Everybody see what I did there? Now I can divide by 3 and not have fractions. So ln x equals 2. Ayrton, stay awake, please, sweetie. Now, I gotta get rid of that logarithm. But there's no base, or is there? It's e. Isn't the base here e? So I'm gonna start with e to the second power equals x. Now we talked about this last time, that answers are with e's are okay. It's okay to say e squared. All right, let's look at the next one. What about this, Joshua? Oh, you stretched at the wrong time. Now you get to tell me what thought you have about this problem. Subtract 2, I love that, that's a great idea. So negative log x plus 1 equals 2. Perfect, then what, Joshua? By?
Log.
No, we can't divide by, all we can divide by is this number right here. So what number is out here? Negative 1. So we're going to divide by negative 1. So we have our log by itself. And then we'll loop-de-loop. Don't try to loop-de-loop until the logarithm is all by itself. So we have to get rid of that and we have to get rid of this. Now what's the base here? 10. So 10 to the negative second equals x plus 1. What does 10 to the negative second mean? 1 over 10 squared, which is 1 over 100. So x plus 1 equals 1 over 100. And now I have to subtract 1. So x equals 1 over 100 minus 1. Anybody have a thought on that? What's 1 over 100 minus 1? Well, wouldn't it be minus 100 hundredths? What's 1 minus 100? Negative 99 over 100. There's your answer. Don't let the arithmetic mess you up. You guys are smart. You can figure this out. Just be patient. Jocelyn, what do you think we might want to do first here? Divide by 5, that's exactly right. And remember, when you divide, all it does is cancel that. It doesn't change anything else. So log 2x equals 2. Sydney, now what?
There's a 10.
There's a 10. Our base is 10. 10 to the second equals 2x, perfect, and 10 to the second means 10 times 10, which is 100. So 2x equals 100, and it looks like x equals 50. Stomp on your feet and break your toes, you're not gonna be able to play basketball. Stay awake. All right, here we go. Caius, step 1.
Subtract the 1 over.
Yes, indeed. So 3 log base 2 of x equals 6. I'm just gonna subtract 1 from both sides. Perfect. Elijah, next, what shall I do? Divide both sides by 3. Remembering all it does is cancel that, everything else stays the same. So log base 2 of x equals 2. And then Ayrton, what happens now? How do I get rid of this logarithm? I need to get rid of him. so what am I gonna do? I'm gonna do it. So what number do I start with? This 2 right here, I start with him. So 2 to the second equals x. So x equals 4. All right, Taylor, you're on for this one. Add the 3, so 2 log base 3 of x equals 7. Do I copy this right? Okay. Now what? Divide by 2. So log base 3 of x equals 7 halves or 3.5. And then loop-de-loo, this is not going to be very pleasant. 3 to the 3.5 equals x. So I don't know what that is, so I'm going to use my calculator. Everybody know how to raise 3 to the 3.5? Use your little caret button. Did you get 46.7654? What did you say? You don't even have a calculator in your hand. You are stressing me out. All right, did anybody else get 46.7654? Okay, so the reason I used the calculator is because that didn't turn out to be a whole number. Like the rest of them did. All right, we have one more page to do, and these are all, at least the first one is exactly like we just did. So this one we should be able to handle. The rest of them look a little bit more complicated. All right, so, Kamari, I need to get rid of this logarithm. How do I do that? I'm gonna loop-de-loo it, that's right. And what number do I start with? What number do I start with? The 3. So 3 to the second equals 5x plus 7. Gabby, what's 3 to the second? 9. So to solve this, what am I going to do now? I made it a 9. So Gabby, what am I going to do to solve it? Subtract 7. So 2 equals 5x. I got x equals 2/5. How does that sound? That's a pretty easy problem. Would you agree? Especially after all the ones we've done this morning. Now the next one is not quite as easy. What is different about this problem? Can anybody see what is different about this particular problem? There's 2 logarithms. Now listen to me, this is big. You can't solve an equation that has more than 1 logarithm on either side. It's not possible, okay? So if I am going to work on this equation, then I absolutely must find a way to put these together. I don't want to have 2 logarithms. I got to mush them together and have 1. That's solvable. This is not. So this goes back to something we talked about a few days ago. When logarithms are added, do you remember what that means about the numbers themselves? They've been multiplied. So when I smush this together and make it 1 logarithm, just this left side here, when I make this 1 logarithm, it's going to be x squared minus 3x, because this and this get times by each other. When that's a plus, when you have log plus log, it means the things you're logging have been multiplied. So x times x minus 3, I distribute and get x squared minus 3x. Now I can do this problem. What's the base? 10. So you're doing 10 to the first equals x squared minus 3x. What's 10 to the first? 10. So 10 equals x squared minus 3x. How do I solve something like that? Set it equal to 0, so move that 10 over. And then what? Either the quadratic formula, or if you can see that it factors, you can factor it. But either one is fine. This one does factor. Does anybody see how? Minus 5 plus 2. Now, again, if you don't want to factor it, you can use the quadratic formula. This is a quadratic equation. So I get two answers. My two answers are x equals 5 and x equals negative 2. Now, I'm going to dig back in that memory bank one more time. If I go back to the original problem, and I let x be negative 2, is that possible? Think about that. We were typing these in on our calculator, and what did we discover when we were typing them in on our calculator? Can you do the logarithm of a negative? No, you can't. So this is an extraneous root, and the only answer to the problem is 5. If you don't remember what I'm talking about, press log negative 2 on your calculator right now, and it will say error. You can't do it. You can't take the log of a negative. Problem C looks like almost the same thing. So this will be good for us to work back through this again. It's almost identical. So think about what we just did. What will be step 1? Squish it together. And when you squish it together, it's going to go together. One logarithm now, instead of 2, you're going to squish it and make 1. And since that's a plus, we're again going to multiply these two together. So that'll be x squared plus 3x this time. When you squish it together, you're either going to multiply or divide. And if it's a time, or excuse me, if it's a plus, you're going to multiply. If it's a minus, you're going to divide. All right? Now what? Q, now what? Put a 10 here. We know the base on that is 10. And we do, so 10 to the first equals x squared plus 3x. Then, sincere, what do we do now?
10 to the first, x squared plus 3x. And then you move it to the other, you move the 10 to the other side. And then,
So it'll be minus 10 on the other side?
yeah. And then you get the same answer on the last one.
And then that factors, only the signs are going to be different, right? But it's going to be factored the same way. X plus 5, x minus 2 this time? So two answers again, -5 and +2, and just like before, what's gonna happen? Gonna have an extraneous. You can't take the logarithm of a negative number. So whatever x is, it cannot be negative. All right, D, just cross off D. That one, I keep meaning to change it. I keep forgetting to that the math is just awful. So it's not worth the effort. So just cross off D, and we'll go straight to E. Just a few more, guys. Come on, hang in there. Who's got a plan? Thought? Idea? We're gonna push them together. Can't have two. Kids, you cannot have two logarithms on the same side of the equation. You've gotta put them together. So this is gonna be the log base 5 of these two things times each other. I don't want that to look overly complicated, but I need to multiply these two things together, don't I? When I put it together. And that's gonna be a FOIL. What do I get when I FOIL x plus 4 times x minus 4? Go ahead and multiply that out. Would you get x squared minus 16? Because you get minus 4x plus 4x. Now what? Loop-de-loop. So 5 to the second equals x squared minus 16. What's 5 to the second? 25. I can solve this a couple different ways, but how about if I just add 16 and take the square root? Will that work? Pretty handy and easy. So x equals the square root of 41. Technically, it's plus or minus, but it can't be negative. So it's just, we're just gonna keep the positive square root of 41. Anybody have a question about that? I feel like I went through that one kind of fast. Anybody have a problem with that? What's different about F? I'm gonna make something up here. I'm just gonna say x minus 2. I can't read. Can anybody read that? I can't. So I'm just gonna say x minus 2 there. What?
3 logarithms.
There's 3 in this problem. Okay? Now, here's the rule. You can't have more than one on each side. So it's okay to have this one over here. There's nothing wrong with that. But these two have got to go together. You can't have 2 on one side. So how am I going to mush these two together? Notice it's a plus. So I'm going to do what? Multiply those? So won't this just be 4x? Now wait a second. These other problems didn't have a logarithm over here, so I could loop-de-loo. No loop-de-loo in here, kids. That won't work. Well, let's use our common sense. If the log of red equals log of blue, what might be a natural conclusion? That red equals blue? If they have the same logarithm, if the log of my right hand equals the log of my left hand, don't these have to be the same thing? So if you have one log equals one log, you can drop those out and just solve the other part of the equation. You can't do that on these problems because you only have logs on one side. If you only have logs on one side, you have to loop-de-loo. But if you've got logs on both sides, you can just drop them out. So 3x equals negative 2 and x equals negative 2/3. Can x be negative 2/3? So that problem has no answer. I gotta make up a different number for that side. All right? Now, I didn't quite finish this yet. I'm gonna go ahead and assign 3.5 because we're just about done with it. So that'll be due on Wednesday. So 3.5 is due on Wednesday. Just about done with it. We have office hours on Wednesday.